I'd like to welcome, as the next speaker, Yaron Kretchmer, who's Senior Manager of Engineering Infrastructure at Altera, and his team is responsible for a variety of activities. Yaron is actually leading his team and I think instituting a lot of changes and advances at Altera, which I think has basically elevated their ability to do IP-based design quite significantly. As such a leader, please join me in welcoming Yaron to the stage.
Great. So I'm going to continue the thread about how do you win the hardware design race and talk about my 4 top technologies and how did we implement them and to what extent. So the one issue that we struggled with previously is we had multiple data sources, multiple repositories, using multiple systems from different vendors. And what this caused is difficulties in staging one consistent set of deliverables. So if you imagine that you have your full custom deliverables in one system and your SOC deliverables in another, and you're interested in staging one complete collateral, that becomes difficult when you have multiple data sources. So in addition, we had a combination of legacy systems and systems that were introduced more recently. What we transitioned into is one repository, and we made a concerted effort to highlight the similarity of use models between IC Manage and Perforce. What this let us do is version everything in one consistent way and get to a point where you are able to stage one set of collateral that contains both your IP and your software. And for us at Altera, this enabled us to stage much more quickly. So the other challenge we had is, what do you do with test benches? So test benches are an integral part of your IP development, but do you have them as part of your data management system? Some people do, some don't. Historically, we used to treat some test benches separate from the way we would treat our IP, which made it difficult to share those test benches with your IP deliverables. So what we moved into with IC Manage and Perforce is an ability to integrate your test benches with your IP, which lets you leverage all the power of branching that comes with Perforce through IC Manage. This lets you stage multiple versions of the IP, multiple versions of test benches, and branches as you do your development. So one obstacle we had internally is a fear of checking in large files. People had a bad experience with using legacy data management systems, and checking a large file used to take a lot of time. Just one anecdote that I want to bring, that's part of the Perforce conference, where we saw a presentation from Pixar that just checks everything into Perforce, with their biggest checking being more than 1 terabyte. We haven't been that adventurous, but we have checked in fairly large databases coming from PNR. We've checked a multitude of SPEF files, and IC Manage and Perforce just deal with that at pretty much wire speed. So a third direction, I'm going to continue the theme that Nigel talked about, is a bidirectional link between our bug tracking system and data management system. And we both know that a variety of engineers are forced to tape out designs which include bugs that they are unaware of. But I'll also say that in some cases, when schedule trumps the ability of fixing all your bugs, you need to release a device to production which has bugs that you are aware of, right? So it's not only the things that you don't know, it's the things that you know, that you made a conscious decision to tape out even though there are existing bugs that you know you can work around. So inability of doing a bidirectional relationship between your data management and bug tracking lets you see exactly where your bugs are, so that when later on you have a chance of fixing those, you know exactly in which stage of the data management system do you need to do that. Now, one lesson that we've learned is that it's a good thing to choose your bug tracking system carefully. Some systems integrate out of the box with Perforce and IC Manage, some don't. But with that little caveat, the integration is crucial and very well supported. And the last point I want to talk about is verification checklists. The system we put together in Altera is a checklist-based system, quality checks that are integrated into the data management system. And what this lets you do is strike the balance that fits for your company between being too loose in the sense of releasing anything regardless of quality, and too strict, not being able to make any progress until everything is perfect. We've struck a balance where we have some basic checks that are mandatory, but you can still execute a release if you get failures. And there is a release manager, a human release manager, whose role it is to either let a release through or not. So since we had to integrate the system fairly quickly, we set the goals in terms of reaching a common platform top-down. We ensured that the infrastructure was adequate, so we invested a lot in the hardware needed to enable the different sites that we have to work successfully. It took us about a month to release everything to a small group and another month to deploy broadly. And we accelerated the adoption by keeping the deployment as much as possible to just out-of-the-box usage. What this lets us do is leverage the existing training, keep to the existing and very well-documented data management command structure, and let us leverage the really great performance that you get by the system. So we kept the amount of triggers, the amount of layers that we put on top of the system to a minimum just so that we can keep it simple. Okay? Now, in my mind, how do you measure success? In my view, success of a data management system equals boredom. So your goal is to fade into the background, to basically get out of the way so the people that do the real design can work unhindered. So we stage our first production design. We got it to a point where it's used by 600 people in 3 major sites. Working so far, I've just checked this morning, and it's actually up to 13,000 workspaces. We do a lot of regression based on the data management system. So once we get to that point where people were just using the system, this was our measure of success. And that's all I have. Thank you. We use behavioral IPs at a variety of levels, starting at C, going through system C, ending up at system Verilog and just Verilog. We really do not see a major difference between behavioral IP and any other level of abstraction. You have very robust development methodology. So in my mind, at least, a behavioral IP is pretty much software. So as far as data management systems go, there are very robust methodologies on how to deal with a data management system when you do software development. There's a lot of co-development opportunities, branching and merging, etc. All of those, since IC Manage sits on top of Perforce, are readily available through IC Manage. We use them quite successfully. The team that is doing the behavioral IP development and the testbench development is definitely the most advanced in our design community. So we have not run into a lot of issues with that. I would really be interested in understanding what issues we should have run into and didn't. So what we've done is we have kind of most EDA tools out there and most revisions of those EDA tools just installed. And what we did is we created a set of configurations that are controlled by Perforce, and those are stageable on a per workspace basis. So to answer your question, the way we capture the metadata, essentially a signature of what that set of tools was that apply to a certain revision. We capture that in the data management system. So you can go back and say what was the set of tools that was used for that specific workspace. It seems that the models are all applicable. The difference is whether you stage the data, if you will, of the tool, or you stage the metadata, right? So you can either have the tool itself installed and reinstalled, say on a workspace basis. This doesn't scale. Or you can have a central area, if you will, where all the tools are installed and you just capture the metadata. The metadata is small enough that you can now revision it together with your workspace. We store it in IC Manage. One of the system gives you a capability of controlling the number of versions that you keep on a per file or per file type basis. So as Simon was saying, we just keep it to a minimum. There's really no point in saving more than a single version. We do revision it in, but I think it's as valid to keep it. Very carefully is the short answer. And one of the advantages of the system that we have, where all the tool versions are fully revisioned, is that it gives you a mix and match capability that is fully trackable. Once you have that and you're careful about not using the wrong tool at the wrong time, then you can always go back, find out where the error came from and fix it. So my answer would be is you integrate either the tool installation itself or the metadata of which tool and flow you're using into your data management system, and then once an issue is tracked, you can always go back and find out where in the tool chain was the problem.